Okay, so yesterday we were talking about adding and subtracting algebraic fractions. It's exactly the same as normal fractions in the sense that you have to have the same denominator. So if it happens that you have a variable in the denominator, then you have to take that into account and multiply top and bottom by that variable, simplify, multiply top and bottom, all those sort of things. Then if you have any issues from yesterday, make sure you ask me today. Go through that. So again, because the point is, we're going over it, firstly to make sure you know what you're doing, and secondly, to increase fluency, right? So that you can start doing these processes without thinking about it. That you're able to just naturally do these steps, because these are just things, skills that you'll need to do to solve problems later on. So at this stage, we're just gathering the skills we need to do things afterwards. Right. So, if we have a look, we're going to talk about multiplying and dividing algebraic fractions. So remember that when we multiply fractions, you just multiply numerator with numerator, denominator with denominator. Okay? And when you divide fractions, you change the second fraction to its reciprocal, which is swapping the numerator and the denominator, and then you change the division sign to multiplication. Okay, so those are the two things that we need to remember. Multiplication of fractions, top to top, bottom to bottom, and then simplify. Now I'm going to show you a way of doing it that makes things even easier. I think many of you are already doing these sort of techniques, but I'm just going to show you how I think about it. And again, this is to increase the speed of your working out. And remember division. Flip it upside, reciprocal, change the division to a multiplication, and then all you have to do is multiply top with the top, bottom with the bottom. Alright? So that's what we need to do. Let's just check if this is working. Yes, good. So we just finished writing that down. Are there any questions? We're all familiar with how to do fractions? We're good with that? There. Okay, first example here. We've got x over 3 times 5 over x. Now, the technique I've set up here is multiply first, and then you simplify. Alright, but the thing about it is, you can already simplify before you even do the multiplication operation. If I sort of think about this as, put a sort of line across here, alright, I've got in the numerators, I've got x and I have 5. In the denominators, I have 3 and I have x. So if there's a common factor in any of the numerators and any of the denominators I'm multiplying together, I can cancel those out straight away. So either of these numerators and either of these denominators, if there's a common factor, it will cancel out. So what I mean by that is the numerator there's x, and in the denominator there's x. And so I can simply cancel them out. And so what I'm left with is 1 and 1. And so it ends up being 5 over 3. Alright? Or you can do it as, if I just skip over here, x times 5 is 5x, 3 times x is 3x, and then of course the x's that will cancel out, and we're left with 5 over 3. And so this one is just eliminating that first step. You're just looking for factors straight away and cancelling them out as you go. That's what you can. Yes. No, that's fine. Improper fractions are much easier to work with than mixed numerals. Because of multiplication. You can't really multiply mixed numerals easily unless you change it to improper fractions, so you might as well keep the answer in that. Alright, so the first thing is any of the numerators. This is when you're multiplying fractions. Any of the numerators, any of the denominators, if there's any common factors, you can just cancel those out straight away. Okay? So that's the first one. Now the next one is 3 over a times 6 over b. Are there any common factors in any of the denominators with any of the numerators? No, a, b, 3, 6 have no common factors, and so we simply multiply. It becomes 18 over ab. right? 18 over 18. You can't simplify that anymore. It's just a simple multiplication, top with top, bottom with bottom. Now the next one, we have 7 over 2b multiplied by b over 14. 7 over 2b times b over 14. Now, if you look in the numerators and denominators, are there any common factors between all of the numerators and all of the denominators? Yes, b is 1. So there's a b here, there's a b here. So what I can do is I can just cancel that out. So that just goes to 1, and that's 2. Now, is there another one between all the numerators and all the denominators? There are common factors between them. 7, yeah, so the 7 goes into 7 once. It also goes into 14 twice. So what we have is, we've got 1 and 1 on the numerator now, 2 and 2. So 1 times 1 is 1, 2 times 2 is 4. So it's 1 over 4. Now, if you're not comfortable with this method, yes, ma'am. This, that's just the b's crossed out. Okay, so you just have to do the b will cancel out to 1. Or if you're not comfortable with it, of course you can always do it the other way. So you actually multiply. So 7 times b is 7b. 2b times 14 is 28b. And so then 7, that's 4b and b, so that's 1, so it's 1 over 4. Okay? Those are the two ways. But this one clearly is quicker. Because you can identify the factors that you're just crossing out. You don't even have to write the crossing out. You can just see it and automatically write 1 for it. Alright? But to get to this point, you may have to go through this a little more. Okay? Next one. Five xy over 3 divided by 3y squared over 6. Okay, so it's division here. So what do we have to do? Math? Yeah, multiply by its reciprocal. So we're going to do that first. 5xy over 3 multiplied by 6 over 3y squared. So now we can notice a few things that we can cancel out. What is one of the common factors between numerators and denominators?
Y.
Yep, so the y, so we've got y squared, which is 2y, y times y, and then we have y here, so that's going to cancel out. So y squared just goes to y. We divided it by 1 of these y's. What else? 3. So we've got 3 on the top, and actually we could have simplified this from the start. So I'm just going to cancel out that one, and then that 6 divided by 3 is 2, and so that's where we end up. So we've got now 5x over 3 and 2y. And so what we're going to end up with is 10x over 3y. Yes, this one? Yeah, we could. This one? Oh, yeah. Oh, this one? Oh, no, because... No, I'm cancelling the factor of 3 from here. So if you cancel out the factor once, then there's not another 3 that will cancel out. I've just divided top and bottom here by 3. So it just happens. I could have done that for this one and left that 3, but I can only divide it once. Then you're not going to be multiplying them together. Right. So the other method, of course, is you just do this operation and you're able to do it step by step, and then you cancel. Okay, so it's a personal preference thing, but personally I think this way is quicker because you're seeing it and you're not working with these big numbers that you have to work with as you do it. Right. Last one. Now 9x squared over 2 divided by 3x times 5 over 12x. So when you have cases like this, you just go from the left and sort of ignore each one as you go. Alright? That's the way that I approach it. Do the first two, and then go on to the next one. So we can rewrite it. We have to find the reciprocal of the second, so 9x squared over 2, multiplied by 8 over 3, multiplied by 5 over 12x. Now, in terms of cancelling out, though, we can actually cancel out, look at all of the numerators and all of the denominators and cancel out any common factors. So what are the common factors here? Good. All right, let's go with the 3 and the 9. So the 3 goes into 9 3 times, and it also goes into 3, so that goes to 1, and we go to 3 here. Okay? The next one was, we've got x's that will cancel out. So x cancels out here, that's in the denominators, and this one's in the numerator, x times x, so we're only left with one lot of x, and then, sorry, we had a 2, yeah. So that goes to 1, and then that will go to 4. So we're left with 3x, 4 and 5, 1, 1 and 12. Okay, so 3x times 4 is 12x times 5 over 1 times 1 times 12, which is 12. What do we notice here? Yep, certainly could. Yeah, you can do that, or you can do it after this step, but if you want to do it that step, so lovely. What's in this step here that you can simplify? 12. Alright, so that would cancel out and that cancels out. So we're simply left with 5 times x, which is 5x. Okay. Take it step by step. I don't mind what method you use. I'll say it again. It's about increasing your speed in these operations. In the end, these sort of skills are not the point of these sort of mathematical ideas. These things have to be used in much sort of higher theory stuff, which you're going to get to in later years. And so to be able to achieve those and do those sort of problems, you need to be able to do these things quite quickly and to do them well. Okay, so it's about practice and building up the skills that you need. So exercise 2.07, you do all of it, and then we'll see how we go.